This video will show you some very good habits to get into to get good performance from your Ammco brake lathe. We are using one of our rebuilt Ammco 4000 brake lathes with the standard cups and cones and with the newer style spring silencer. Also, we're using our Super Duty tool bits. They are almost twice as thick as the standard tool bits to give a better cut while lasting much longer. We carry all of the tooling and accessories you'll see in this video. Safety glasses or a chip shield should always be used whenever operating the lathe. Proper clothing should also be worn. No loose clothing, no hoodie strings. Check the minimum discard specification that is cast in the rotor, then mic the rotor to be sure it will still be in spec after machining. Cleanliness is very important in machining rotors and drums. Don't forget, we're working with tolerances in the thousandth of an inch, so any grease or chips can affect your mounting. Special care should be taken with larger diameter rotors. Clean the rusted scale from the rotor hat on both sides using an air sander or wire wheel. Clean the centering hole so there is no scale or rust. Clean the grease and shavings off the arbor. The arbor threads and nut should also be cleaned, as the chips will act as an abrasive and wear out the threads. Find the correct cone that will properly fit the centering hole in the rotor. Find the correct cup that will fit inside the head of the rotor, not on the casting portion. Bigger is better to prevent vibration. Be sure there are no nicks or burrs on the clamping lugs or mounting face of the cup. If your cups are bent or the arbor hole is worn out, they should be replaced. Do not use the cones or bearing adapters on a press or to install bearings. These are precision pieces and manufactured to very close tolerances. Pressing or beating on them will destroy their precision. Dropping them is a bad idea too. The cups must be clean, no grease or chips. We use a DA adhesive sanding disc stuck to the bench. Clean the back side of the cup so there are no grease or chips. Important, clean the inner cup mounting face for every single rotor. All these things take time, but in the long run, it will save you a lot of time by getting a good true cut the first time. Mount the clean inner cup, spring, and centering cone on the clean arbor. You should hear a nice metallic sound when the cup bottoms out on the arbor. Put on the rotor and then the outer cup, being careful not to drop the rotor on the arbor. Use the heaviest double taper adapters for spacers, then the rubber self-aligning spacer against the arbor nut. It is important to use the self-aligning spacer because it helps compensate for any unevenness in the adapters of your setup. The arbor nut is a dual-purpose nut with a short threaded side and a deep threaded side. Use whichever side works best. When tightening the arbor nut, put the wrench at about the 1 o'clock position and hit the wrench a couple of times with the palm of your hand. It does not have to be excessively tight. The spindle speed is very important. On larger rotors, the spindle speed should be slowed down. Most rotors will be cut using the outer sheave of the pulleys. If you are machining a larger rotor, the spindle speed should be slowed down by moving the belt to a slower inner sheave set. To do this, turn the ball knob on the back of the lathe clockwise to lift the motor and release the tension of the belt. Move the belt to the desired sheave set, then rotate the ball knob counterclockwise until it stops. If your belt has flat spots from stalling the machine or is old and cracked, your cut will be affected. It should be replaced. If your pulleys are worn out, you may not be able to get the proper tension to get the full power needed for heavy cuts. Note, bad pulleys and a bad belt will cause bad cuts. Install the silencer band on the rotor. Looser is better. It will aid in absorbing the vibration. If the silencer is too tight, it will vibrate with the rotor. We carry an extra link for the spring type silencer so the silencer won't be so tight. We also carry a large selection of the latest silencers. The twin cutter should be kept as short as possible to reduce vibration. Crank the spindle to the right using the drum feed crank handle. Usually a 1/4 inch of the hex shutoff rod on top of the lathe should be sticking out of the casting. You can go further out if necessary, but try to keep it as short as possible. Tighten the red spindle lock knob on the top of the lathe. Be sure the crossfeed red lock knob on the bottom of the crossfeed carriage is loose. Be sure the crossfeed will feed out far enough to cut the whole surface of the rotor. Crank the crossfeed carriage in so that the tool bits are about a ½ inch from the outer edge of the rotor. Center the tool holders on the rotor. The twin cutter should be centered on the rotor so both tool carriers are close to the same distance out of the twin cutter casting. The twin cutter can be angled slightly for big or small rotors. It does not have to be perfectly aligned with the lathe. Best practice is to have both cutters come off the rotor at the same time. Tighten the twin cutter stud nut. As you're standing alongside the lathe, put the wrench at about the 4 o'clock position, snug it up, then give it a couple of hits with the palm of your hand. Start the lathe using the switch on the back panel of the lathe. Check for runout of the rotor using the wrench as a guide or a dial indicator. If there is runout, check the hub to determine if it is the rotor or the mounting that is making the rotor run out. Another way to check for runout is while the lathe is running, slightly snug the right red lock knob on the twin cutter to take out any play in the tool carriers. Bring the right tool bit near the surface of the rotor until it just touches the rotor to make a scratch on the high side of the rotor. Make note of how much runout there is. If there's not very much, you are ready to make your cut.
Okay, we're rolling.
With the lathe on, turn the outer micrometer knobs in until the tool bits just touch the rotor. Then, while holding the outer knob, turn the numbered barrel to 0. There are 2 0 marks. One side is metric and the other side is in inches. Each increment is 2/1000ths of an inch. Back the tool bits away from the rotor. You must take the lip where the pad did not contact the rotor off the rotor before you can make your cut, or you will break or stall the machine. When the twin cutter is about a ½ inch from the outer edge of the rotor, bring your micrometer dials back to the 0 that you got earlier. Do not turn the numbered barrels. Then manually crank the crossfeed out until you hit the outer lip. When you hit the lip, slowly continue cranking out until the lip is gone. Now crank in and cut out the inner lip. You have the twin cutter at the innermost part of the rotor, so you can now set the depth of cut. Turn the outer micrometer knob in 3 marks or 6/1000ths on each side. Tighten the red lock knobs quite securely. If there was not much runout, you can usually clean the rotor in one 4 to 6/1000 slow cut. If you take too small a cut, you'll burn the tips due to no heat transfer into the rotor. If the rotor has a lot of runout or grooves, you will have to take a rough cut and then a finish cut. To engage the disc feed gearbox, put your left hand on the crossfeed crank to act as a brake. Lightly squeeze the crank to put a very light load on it. This is done to ensure the gears go into mesh in the gearbox. Lift the disc feed handle and lightly put it into the desired fast or slow position. You may feel the handle jump or not. Once the crank starts to move, you can release your hand from the crank. Note, best practice is not to leave the machine unattended while in operation. A refinished rotor should be washed with soapy, then clear water to remove the microscopic dust generated during the refinishing process.